What do I want to show in this video? There are practical aspects of heating the tank water and cooling the living room at the same time. I am in favor of double use of the heat pump, that is the cold and the hot side. Remember that usually the heat or the cold of the heat pump is discarded, in summer respectively the winter. And then the experiments and measurements. And please look until the end of the video to learn the most interesting alternatives to get the best of this heat pump, including how I plan to avoid Legionella. Here's the scheme of the system. It is very simple. While the heat pump in the house is blowing cold air, the warm water, orange, goes to the tank through a garden hose of 15 meter. This just falls into a tank of 400 liter. At the bottom of this tank, where the water is coldest, is a submerged aquarium pump that has only one water connection, their output. Let us now calculate for the heat pump a power in kilowatt of 2.5 heat, 1.7 electric, and the difference 1.8 for cold. This 2.5 kilowatt can heat 1000 liter of water each hour, 2.2 degrees Celsius, or our tank of 400 liter with 5.5 degrees Celsius per hour, which indeed I measured. The pump with a specification of 1000 liter per hour needed in practice 30 seconds to pump 5 liter from the heat pump to the tank through only 15 meters of hose. That is 1 hour for 600 liter. Two-way, so forth and back, being 30 meters, it was 400 liter per hour, as I measured, exactly the capacity of the tank, so 1 tank per hour. Because the pump capacity is equal to the tank capacity, the hourly temperature increase is equal to the temperature difference between in and output of the heat pump. So that is the 5.5 degrees Celsius of before. That doesn't sound bad as temperature difference between in and output of the heat pump, and so this flow of 400 liter per hour is enough to take away the heat. Connecting the heat pump. The heat pump has 32 mm connections. The hose is only 19 mm outside diameter. The solution is to go to the garden shop. It is important to make it tight because the heat pump was tried in the living room and you don't want to lose water. Now about connecting the pump. It has to be connected to the hose but also to the power. Here is our power pack that delivers 230 volts AC. Talking about the water connection, the hose must go through the cover of the tank and you need 2 holes. I want to be able to close it when I take away the hoses for some reason, so I took a drill with the diameter of a wine bottle cork. And finally, you have also to take care of the correct flow direction in the heat pump. Here it's the big one. I also measured the 2 water temperatures two-way from the tank side. This was including the heat loss in 30 meter of hose between the tank and the heat pump. Here are the results each 15 minutes for the air temperature and the tank water temperature, which is the input temperature for the heat pump. The first experiment was carried out in the morning with much heat from the kitchen, where we were active, so I didn't put them into the graph. The second time was afternoon when it was 34 degrees Celsius outside. It was in the old part of the house with single glass still and a challenge for the heat pump to cool these 70 cubic meter of living room. The heat production was calculating from the water temperature raise 2.6 kilowatt, a bit more than the 2.5 kilowatt from the specification, probably because of the low temperature of the water. With warmer water we see indeed that the consumed power increases, so it's less efficiency. The cold production was not so easy to calculate with the air temperature decrease, because the wind speed was unknown, but let's subtract the power consumption from the heat production and we get 1.9 kilowatt, so 2.6 minus 0.7. The COP, the coefficient of performance, is the warm multiplication factor. It was 3.7. And the EER, that's the cold multiplication factor, was 2.7. Therefore, if both sides are in use, so the hot and the cold side, the total multiplication factor is 6.4. That means you get 6.4 kilowatt for each kilowatt electric you put into this heat pump. That's not bad. Now let's talk about the 3 champion alternatives to use the water-air heat pump. This is the bonus on the video, because it gives you the conditions that might match with your situation, and it allows to get the best of the heat pump. Number 1. The big rain water store underground. We have here in Sicily a cisterna, an underground reservoir of 70 cubic meter at 17 degrees Celsius, very constant. We can use it cold and drop the water back in the reservoir, or use it for irrigation of the garden. 70 cubic meter is a huge amount of cooling water, and the interface with the ground is about 100 square meters, so if you circulate the water, it will cool off on the earth. In some way, this is like geothermal energy. Second, cooling only when filling up the tank, the water tank, to have the best of the cool water of the grid. Nobody says that the tank has to be refilled as soon as some water is consumed, which is normal for this kind of reservoir. The cold water supply to the tank can be kept closed until you want to have the cold air from the heat pump, and only then you take cold water from the grid to cool the heat pump. Let's make a calculation. In Italy, the consumption of water per person per day is 220 liters. That will take 220 times the specific heat of water, and then times the temperature difference. Let's say that is 25 degrees, where it will come, minus the temperature of the grid water, 17 degrees. And then you get more or less 2 kilowatt hour of heat, which is needed to bring the cold water to the ambient temperature of 25 degrees per person per day. If you heat this water up until 25 degrees with the heat pump, this will give you at the same time 72% of cold, or 1.5 kilowatt hour of cold per person. A family of 4 needs 880 liters and can use this swimming pool heat pump to produce 4 persons times 1.5 kilowatt hour of cold is 6 kilowatt hour of cold, with just this method of super high efficiency. If you need more, then it can be done with the heat pump at less efficiency, so going at higher temperatures of the water, beyond the ambient temperature. For example, preheating domestic hot water. You even don't need the water pump, because you will use the pressure of the water grid and limit the entering water flow 300 liters per hour. Maximum. I really want to try if it's possible to go straight from 17 to 14 degrees with this heat pump. This value, 300 liters per hour or less, together with the daily consumption of water in your house, also tells you how much hours of super efficient cooling you can have. And this method has not the disadvantage of Legionella, because the water is heated up afterwards to a temperature that kills the bacteria. Okay, here I show you another twin tank that I used for another heat pump experiment, which is based on water. But I might use one of them also for this swimming pool heat pump.
like we said.
Next time we will try to make this heat pump more silent. It should not need intervention on the compressor. It is the fan that is making the most noise.